Hello everyone, welcome to BRYT Engineering. Today we are going to look at op-amps, and then this type of op-amp that we are going to look at is an inverting op-amp. So op-amp is just an abbreviation for operational amplifiers. And in order for you to know that an op-amp is either inverting or non-inverting, we look at where the input part of the system is attached to. So when you have this, the input part is attached to the negative part. So this is an inverting amplifier because the output is going to be inverted based on the input. And then whenever the input is attached to this positive bar, it means that we are going to have a non-inverting op-amp because the output is not going to be inverted. So in that case, we are just going to look at the transfer function of this diagram. And interestingly, for an op-amp, the transfer function of this op-amp is the same as the gain of this op-amp. So for an inverting op-amp, and particularly, please, this is a closed loop operational amplifier. So for a closed loop operational amplifier which is inverting, the transfer function or the gain that we are going to get, which is going to give us V0 of S over V1 of S, is equal to negative Z2 over Z1. We are bringing this negative here because of where the input is attached to. So because it's attached to this negative, now we have this negative here. So now we have to find Z2 over Z1. So interestingly, Z1 is just the addition of the impedances at the input side, and then the Z2 is also the addition of the impedances of the feedback system. Remember, we said this is a closed loop amplifier. So we are going to find Z1 and we are going to find Z2. So we know that our Z1 is equal to R1 plus C1. But then we are finding this transfer function in terms of S. So it means that we are going to use Laplace to find it. And we know that when you convert R to Laplace, it's the same R. But if you have to convert a capacitor to Laplace, you are going to get 1 over SC. So here, we've been given R1 as 500k ohms and then C1 as 2 microfarad, right? So our Z1 is equal to 500 times 10 raised to the power 3 plus 1 over SC. And in this case, our S is just 2 times 10 raised to the power negative 6. Right. So in order to find this, we are just going to compute our Z1, and our Z1 is going to give us 500 times 10 raised to the power 3 plus 5 times 10 raised to the power 5 over S. And here we can just find S, we can just cross multiply this by S and then find the summation of these two. We are going to get S into brackets 500 times 10 raised to the power 3. So plus this, the numerator, which is the 5 times 10 raised to the power 5, all divided by S. So in this case, we are done computing for Z1. And then our Z2 is similarly also equal to R2 plus C2. So just like we did here, changing this to Laplace, we are going to get R, but then this side we are going to get 1 over S multiplying by the capacitance value. So R2 is given to us as 100 times 10 raised to the power 3 plus 1 over S, and with our capacitance value is also 2 microfarad, so 2 times 10 raised to the power negative 6. Right, so we are getting 100 times 10 raised to the power 3 plus 5 times 10 raised to the power 5 over S. Just like we did with the Z1, we cross multiply, so we are getting S into brackets 100 times 10 raised to the power 3 plus 5 times 10 raised to the power 5, all divided by S. And then from the onset, we said that our gain or our transfer function is just the negative of Z2 over Z1. So V0 of S over V1 of S is equal to negative, our Z2 is S into brackets 100 times 10 raised to the power 3 plus 5 times 10 raised to the power 5 all over S divided by our Z1, which is also S into bracket 500 times 10 raised to the power 3 plus 5 times 10 raised to the power 5 divided by s. So when we are dividing this by this, we just have to change this sign and then multiply it. So we are going to get this multiplied by, then we flip this upside down. So we are going to get s divided by this whole expression. So this s is going to take away this s. So what we are left with is going to be minus of s into brackets 100 times 10 raised to the power 3 plus 5 times 10 raised to the power 5 divided by this, which is s into brackets 500 times 10 raised to the power 3 plus 5 times 10 raised to the power 5. Alright, so in this case we can just bring out 10 raised to the power 5 because 10 raised to the power 5 is common to this and this expression. Here we can write it as 1 times 10 raised to the power 5. So we can just bring that one out. And similarly, we can also bring this out too because this is also the same as 5 times 10 raised to the power 5 because of the zeros. So we can just bring that one out. So it's going to result in negative of s times 10 raised to the power 5 into brackets 1 plus 5. And here we are also, with this we are also going to get 10 s of 10 raised to the power 5 and into brackets here we are getting 5 plus here, which is, so straight away this 10 raised to the power 5 can take away this, and then interestingly this is, this is multiplied by the s. So what we are left with is now going to be negative s plus 5 over 5s plus 5, like this, and this is going to be our answer. But then from here we can also just put this into brackets so that we can at least substitute 5 hours because 5 is common to these two. So we can say that this is also equal to negative 1 over 5. We are just taking this 5 out, and then into brackets s plus 5 will still remain the same, but then here instead we are going to get s plus 1. Thank you very much for watching this video, and if it has been particularly helpful, please don't forget to subscribe, share, and then comment.